Hey everybody! Oh my goodness, I am so sorry that we're a couple minutes late here. I was having just a crazy technology issue that I've never experienced before in the millions and millions of these that I feel like we've done. So I apologize for that. Thanks for sticking with us as we sort it out. Boy, this has been quite a week for webinars. Okay, so regrouping here. Welcome everybody to today's webinar, which is now happening, which is great. Today we've got Adrian Messer, who works here with us at UE Systems, and he is going to be talking all things STEAM. So helping you all figure out how to plan, perform, and report on steam trap inspections with ultrasound. So great time of year to be talking about that as people are getting their STEAM systems up and running. So I know you'll learn quite a bit from what Adrian has to share today. Just a couple things before I turn it over to him. So this set of webinars that we've been doing the last couple of weeks is all in conjunction with a bigger effort, which is our Leading Reliability virtual conference. Some of you may have participated when we did this back in July. It was our first event. It was, I think, a pretty successful venture, and we're looking forward to doing another one in January. And hopefully, maybe that'll be the last virtual event that we need to do, because I'm hoping we get to start seeing everybody in person again here soon. But anyhow, this event is done with our friends at Iridicio, RDI Technologies, and Fluke Reliability. So it's kind of a joint effort to put on this conference and to put forth these webinars and the information and content that we've been doing the last couple of weeks. So just wanted to make sure everybody's aware of that. And since we are talking ultrasound today, just a good reminder to those of you on here that use ultrasound, use our equipment, definitely, reach out to us if there's anything we can be doing to help you all with your program. If you need software help or equipment help, just even help talking through other applications you could be using, or how to put good procedures in place. Just anything that comes to mind that we can be helpful to you, certainly while maybe some of us are still kind of stuck doing things remotely or not being able to travel, things like that. So always happy to get one of our trainers hooked up with you on a go-to-meeting, phone calls, whatever it might be. So just don't hesitate to reach out. We're standing by to help you guys improve your programs. So we are recording this just like we do all of our webinars, and I will get it up on our YouTube channel later today. So you can always check that out and check out all the presentations we've been doing over on our YouTube site. We also post a lot of them up on our website as well. We certainly welcome questions, so you can type those into the questions box. I'll be keeping an eye on those throughout the session, and we'll hop in and ask Adrian to clarify things or ask questions that seem relevant to something he's talking about, if that makes sense throughout the presentation. Or of course, we'll have time at the end for some Q&A. And of course, as always, if we don't get to every question, we will for sure hook up with you offline and make sure we get those things answered. I don't have it on here, but just a good day to remind, since we are doing this live, you just never know what little bumps in the road we might encounter technology-wise. So just bear with us if we have any audio issues or Wi-Fi gets slow or anything like that. We'll do our best to get those things resolved just as quickly as we can. And just mind, pardon any barking or kids in the background that you might hear. I do still have a full house until we can get these kids back to school. So with all of that, I am now going to turn the screen over to you, Adrian. And Adrian, we will let you take it away.
Okay, awesome. Can you see that okay? I've got the
yeah, looks great.
Okay, great. Well, thanks for the introduction there, Maureen, and thanks for all the useful information that you always kind of lead off with. But just to reiterate what Maureen welcomed us with, again, thank you for taking time out of your day to be with us to talk about steam trap testing using ultrasound. And, for most, this may not be the most exciting topic to talk about, but if you're in a plant, if you're in a facility where steam is in use, especially for, process or product related applications, then, it's very important to you. So, keep that in mind. But, we'll go through this, and we're going to talk a lot about reporting and documentation as well. So it's one thing to go out and inspect and test steam traps, but then it's another to be able to then extensively, report and document your findings. So we'll talk about a couple of different ways to do that. But again, thanks for being with us. And talking about some of these energy-related applications with ultrasound, I always like to lead off with some statistics. But, if we just think about how the steam is generated in our plants and facilities, we look at the fuel, typically it's going to be some sort of, natural gas or, some other type of fossil fuel. But if you look at what the U.S. Department of Energy has to say about that, over 45% of all the fuel burned by U.S. manufacturers is used to generate steam. If you're in a typical, facility who is using steam, then you can realize steam savings of up to 20% just by simply improving the steam system. Now, improving the steam system, that also includes testing and then repairing any faulty steam traps. And, similar to a statistic that air compressor companies give out in relation to, if you look at, as much as 30% of the compressed air generated is lost to leaks, a similar statistic as well is approximately 20% of the steam leaving a central boiler plant is lost via leaking steam traps. So we can pretty well know that at a minimum, we're going to realize or gain back at least 20% savings related to energy waste with failed or leaking steam traps. Now, at UE Systems, we always promote a multi-technology approach. So in our case today, with talking about steam traps, we're talking about making use of ultrasound and temperature, not necessarily an infrared camera. Certainly, if you have one, that's great, but just a simple spot radiometer just to be able to take inlet temperatures and outlet temperatures on these steam traps. So again, combining temperature and ultrasound, similar to the way we talk about using ultrasound and vibration together with mechanical or rotating equipment inspections. Similar to, we really promote the use of ultrasound and infrared together with an electrical asset condition monitoring program. Again, here, one technology can't do everything. Well, we certainly don't want to be relying on one technology to make a good diagnosis on what the health of that asset or that steam trap is. So, also in your plants, in your facilities, we want to try to create awareness and safety. One way to create awareness of how we need to be more mindful and how we need to better maintain our steam and our steam system is by putting a dollar amount to it, just showing how much energy waste can be associated with failed or leaking steam traps. If you're in a plant where there's some excessive high pressure steam in use, then certainly that becomes a safety issue. Training. We want to make sure that the personnel who are going to be responsible for maintaining our steam systems, maybe even possibly doing the steam trap inspection itself, we want to make sure that they're properly trained on not only their ultrasound equipment or their infrared or temperature equipment, but also just training them on the different types of steam traps, what their operation is, what their sound characteristics are when it comes to how they should sound when we listen to them with ultrasound. But then also we think about reporting and documentation. And like I said, we're going to be talking a lot about that in this presentation because anytime that we can use our condition monitoring tools to be able to put a dollar amount to what it is that we're doing, that just really helps to create awareness and buy-in for exactly what maintenance and reliability is doing. So it's a way to showcase maintenance and reliability as providing value as opposed to just being a cost center. Unfortunately, maintenance and reliability a lot of times is viewed as a cost center rather than providing value. So we're going to show you a way that we can do that with our ultrasound reporting of our steam trap inspection once we're done with that survey. So the purpose of an ultrasonic steam trap survey should be to identify and correct faulty traps that negatively impact energy use and cost. So, there is a sustainability piece now, and, a lot of plants, a lot of factories that I go in, that is of high interest, especially in this day and time with, this period of time that we're in related to COVID. Lots of people are wanting to focus on ways that we can cut back. Now, this topic is very timely for this time of year because it tends to be the time of year when people start to focus on getting their steam system, optimizing it for these colder months that we have coming up over this winter. But, you may also have, again, like I said, process-related steam where if you have failed traps, that could produce some product imperfections, product quality issues. So either way, if we look at it from just simply a sustainability piece, we want to try to make good use of the resources that are available to us. But then also if we have those failed traps, then that could also create some product quality issues, and that can be costly as well. And then the reporting and documentation piece, which again, I'll show you ways that how we can generate that steam report, and then I'll also provide you an example of that. When we look at ways that we inspect our steam traps, just good old-fashioned, visual. If you've worked in a plant, if you've worked in your place of work for any length of time, it's easy to just get used to the way things are. We go in or if you drive into your plant and you see excessive steam venting to atmosphere, you think, oh, that's always been there. Well, no, it shouldn't be there, even if it has always been there. That's usually a good visual indication that you have some failed traps that are venting too much steam to atmosphere. But if you go out and walk your plant with a purpose, so we purposely go out to just look at our steam traps, look at our steam system, that's a good way to make use of just visual inspection. Look at the steam traps, look at installation. I have been out with people walking their plant, and we look at some steam traps, and we find where sometimes they're installed backwards. I've seen where they've been installed upside down. So again, just making good use of, walking our plant with a purpose. So we go out and we walk our plant specifically to look at our steam system, any design issues, anywhere where we can make potential improvements. That's a good thing. And then we talk about temperature. When we talk about temperature with ultrasound, we're talking about measuring the inlet temperatures and the outlet temperatures. So we need that information in order to generate that steam report that we're going to talk about. And then ultrasound inspection. With ultrasound, again, we're listening for high frequency sound that is above the range of normal human hearing. So we're listening for sound that we can't hear. Well, the source of the high frequency sound in this case is turbulence. To when we make contact with that steam trap, we're going to be able to hear what's taking place within that steam trap. So when that steam trap opens and releases condensate, it creates turbulence, and then it's going to shut back and the sound goes away. Now, there's another sound characteristic that comes into play with floating thermostatic traps and fixed orifice traps that we'll talk about. But again, the source of the high frequency sound is turbulence. So it detects the sound of steam or condensate passing across the seat of the trap, and the instrument responds. So the instrument also gives us a visual indicator. In most cases, if you're using an UltraProbe 2000, that instrument's been around for a long time. You've got a needle that moves left to right. So when that trap cycle is open, the needle moves over to the right, comes back to the left once that trap is cycle closed. Some of the other instruments that we have an intensity meter or a bar graph to where you actually see that going up. when that trap opens, and then the intensity meter drops back down to the left once the trap is cycled closed. So the instrument will also give you not only an audible, so we hear the sound in the headset, but then it also gives us a visual on the display. So if the trap is in the stuck open or the failed open condition, then sound is constantly present. So that creates a tremendous loss of steam because obviously we have live steam that's passing across the seat 24/7. If the trap is stuck shut or in the failed closed position, then no sound will be present. Now, in that case, condensate flow may be prevented, so the trap is not able to release that condensate. Or if we're making contact, really our third response is we'll be able to detect or determine if that trap is leaking by, and that's going to be an intermittent bypass of steam. So those are kind of the three scenarios that we can expect to see and then hear if we're using ultrasound as we're testing our traps. Now, there's a fourth, I guess, but we'll be able to determine if the trap is operating properly. That kind of leads us into going to be the sound characteristics. So regardless of what type of trap it is that we're listening to or inspecting, there's really only two sound characteristics as far as normal operation. Now, turbulence is also associated with some other applications. And again, we think about, the versatility of ultrasound, and that's where, really one of the positive things that we get from, first-time users of the technology, and the reason they choose ultrasound as their first condition monitoring tool that they begin to deploy is for the simple fact that not only can they use the same instrument for steam traps, but they can use that same tool for compressed air leak detection or electrical inspection or bearing condition monitoring programs. But other turbulence related applications are compressed air and gas leak detection, where we use an airborne scanning module. So as opposed to like you see in the picture here, we're making physical contact with in this case, a disc style steam trap. We use an airborne scanning module to walk into an area of our plant or facility, and just by simply listening through the air, we can pinpoint compressed air or compressed gas leaks. That same module would be used for vacuum leaks. So again, with vacuum leaks, instead of like a pressure leak to atmosphere, there's an air in leakage, and that still creates turbulence, and we're still able to hear that with ultrasound. Now, valves, that's also going to be a contact application to where we can check, valve leakage, very similar to the way that we inspect steam traps, but we'll be able to tell or determine if that valve is in the open position, if the valve is closed, or if that valve is leaking by. And again, that's going to be physical contact with different points along that valve, two on our inlet side of the valve and then two on the outlet side of the valve. And then steam traps. We're listening for, internal turbulence across the seat of the trap. So again, when that trap cycles open and releases condensate, and then it shuts, that process creates turbulence. No different than if that trap is leaking by or in the failed open position. Turbulence is still the source of the ultrasound. And then steam leaks to atmosphere. That would be the same module that is used for compressed air and gas leak detection and vacuum leaks, to where we can hear steam leaks to atmosphere. Now, sometimes you visually can see it steam leaking to atmosphere, but in some cases not so much. So if you have just simple leakage around a valve stem or around a fitting, you may not always be able to see that visually. But you can certainly detect it and hear it with ultrasound, and that would be the airborne scanning module for steam leaks to atmosphere. So again, it is a physical contact application. So again, in the picture here, you see an UltraProbe 15,000 with the stethoscope module, and we're making contact on the outlet or the discharge side of that inverted bucket trap. Now, the standard stethoscope module in our kits, you can extend that out approximately 31 inches. So with that module that you see there, we could unscrew that black piece and then it will come with 3 aluminum rods that we can extend out up to 31 inches. So again, if you've got a steam trap that is inaccessible due to distance or guarding, we can go 31 inches with just that stethoscope module. Beyond that, there is a telescoping pole that we can use that has a stethoscope module on the end of it. That gets you out at about 7 feet. So one end would plug into your ultraprobe, and then the other would be a wand, a handheld wand that would be at its full length would be approximately 7 feet. And then beyond that, we would need to look at other means. So we've even worked with a couple of facilities over the last year or two to where we can do remote mounted sensors. So we do have some high temp remote mounted sensors that you can mount to your steam trap discharge orifice location. That those sensors can either plug in directly to an ultraprobe, or we have some that have other data transfer means, like a 4 to 20 milliamp output that you could monitor or wire into any kind of existing monitoring system. That way we can listen to that steam trap and do that remotely, and we can do it safely, regardless of where that steam trap is located. You know, we think about ultrasound in general. Again, we're listening for sound that we can't hear. So because of that, we're able to use the technology in what would consider to be typically noisy or just loud ambient noise environments in a typical plant or facility. With ultrasound, we typically don't have to be too concerned about those background noises, but because it is a physical direct contact to the steam trap itself, that again helps to eliminate any kind of potential of picking up, I guess, interference from other ultrasounds that may be present in that area. So it will detect the sound of the steam or condensate inside the trap. And then, of course, as that trap operates normally, we'll be able to hear when it opens, when it shuts. Or, again, with floating thermostatic traps, there's going to be more of a continuous flow type of sound. And then ultrasound gives us 2 indications. It gives us a visual on the display of the instrument of what that steam trap is doing. Plus, we have our headset, so we're wearing a headset while we're doing our inspection, so we can hear exactly what's taking place within that steam trap. Now, if you're using an UltraProbe 2000, a 9000, a 10, or a 15, those models have frequency tuning capability. So meaning that we can tune or set the frequency that we're listening at according to what the application is. So for steam trap testing, the frequency setting that is recommended is 25 kilohertz. So that's going to be if we're using the stethoscope module to make physical contact with the steam trap. If we're going to be listening for steam leaks to atmosphere using the airborne scanning module, that frequency setting is 40 kilohertz, with the exception of the UltraProbe 2000. Underneath on the bottom, you've got your 2 dials there. One of them is a frequency adjust. That particular model has a fixed band setting, so you would just turn that dial all the way around until it locks into the fixed band setting. But that is actually 40 kilohertz with some with an additional kind of gain or filter on it. But regardless, if you're using the airborne scanning module for airborne leak detection or steam leaks to atmosphere, that frequency setting is 40 kilohertz. Now, if you're using an UltraProbe 100 or an UltraProbe 3000, those instruments are on a fixed frequency setting. So I tend to refer to those instruments as more of entry-level, operator-friendly type of tool that's on a set frequency that's optimal for multiple applications. So they're pretty much just point and shoot, pull the trigger and you're listening. But those are set on a fixed frequency that's optimal for both the airborne and the contact applications. And then on any of our models, we have a sensitivity adjustment. So the sensitivity A lot of people refer to it as kind of like a volume, but really, technically, it's a gain. So when I increase the sensitivity, I'm increasing the amount of power going down to those piezoelectric crystals inside of the different modules or attachments. So the higher the sensitivity, I guess the more sensitive it is. So that's why on our lower pressure steam or lower steam pressure, we want to have the higher sensitivity because it's just simply not going to be making as much noise as your higher steam pressure systems. So on those systems, you'd want to lower the sensitivity. Now, most of the instruments, especially the digital ones, they'll actually tell you in which direction to turn the sensitivity. They'll either be a blinking arrow pointing to the right, telling me to increase the sensitivity. It's basically just telling me that it's not picking up anything. It's not able to register how much noise that source is creating. So the blinking arrow pointing to the right would be to increase the sensitivity. Now, on the other hand, if we make contact with the steam trap and it's in the failed open position, there's going to be a lot of turbulence. There's going to be a lot of noise. So the arrow may be pointing to the left, telling me to turn down the sensitivity. So either way, we just want to look at our display and it will let us know in which direction we need to adjust that sensitivity. Now, I've already talked a little bit or hinted around to trap identification. So one of the biggest factors to testing steam traps with ultrasound and really any technology is going to be trap identification. So walking up to the steam trap and then identifying what type of trap it is. Because based off of the type of trap, it will have two sound characteristics. So if you walk up and it's an inverted bucket trap, a disc style trap, or a thermostatic trap, those traps are designed or they operate on a hold, discharge, hold operation. So we're listening to the trap and we're going to hear when the steam trap cycles open and releases condensate, and then it's going to shut back. And then typically within a few seconds or a minute later, we'll hear the trap cycle open and then we'll hear it shut. So again, your inverted buckets, your disc style traps, two very common style of traps, thermostatics, those all operate on that hold, discharge, hold operation. Now the other one, or the other sound characteristic, it comes in with our floating thermostatics or fixed orifice traps, to where we make contact with that steam trap on the outlet of the discharge side, and it's more of really a modulating continuous flow. So on most of your F&T traps, you have kind of an inlet at the top of the trap, and then there's a curved housing, and then there's an outlet. Well, inside of that curved housing, there is a ball float in there that kind of sits on a level of condensate inside the bottom of the trap. Well, as that level of condensate changes within the trap, that's what creates that modulating continuous flow sound. Now, in some cases, you can actually hear the sound of the float making a clanging sound inside of the trap. That's really a good indication that the float is in there doing its job and working the way that it should. Now, your fixed orifice traps, they're really designed. It's a designed leak, really. So that trap will definitely be more of a continuous flow kind of sound. Not a whole lot you can do with those, but maybe just kind of monitor to make sure that that orifice doesn't grow too large and winds up leaking too much. But yeah, that's about all you can do with the fixed orifice trap. But again, this is going to be an important slide for you because, again, with trap identification, knowing the type of trap, that will determine what it's supposed to sound like with ultrasound. Now, with any kind of initiative, planning is going to be critical. We walk the steam system. We try to identify areas where the steam is. Now, some of you are probably moaning and groaning because, I've been in plants to where, you may have thousands of steam traps. I've been in plants to where, sections of the plant date back to the early 1900s. So you can imagine over 100 years' time how things have been modified, added to, taken away. There may be steam lines still there that have been in place for decades, but maybe non-operational. So the biggest challenge starting out for most people when it comes to setting up these steam trap surveys, these steam trap routes, the biggest challenge for most is just simply identifying and knowing where all the steam traps are. It's not fun, it's not easy, but heck, if it was that easy, I wouldn't be spending my time here today giving you my thoughts on steam trap testing with ultrasound. Everybody would be doing it, but it's got to be done. It's work that has to be done. So maybe you can start with your blueprints, and then again, you've got to get out and walk the system and know the areas where the steam is in use. Know the areas where, again, like I said, maybe it's no longer in use and hasn't been for some time. You set up a tagging system, set up a way that you want to name the traps. And, really you can do this in our UltraTrend DMS software. So if you don't have a steam trap database in use, or maybe even if it's in, say, Excel, you can set up and use the UltraTrend DMS software that comes with our UltraPro models. A lot of people will use that as their steam trap database. So it just becomes a place for you to set up that trap database. You can add in photos, you can add in infrared images. So, and it really becomes a place where we can then, once we start to build that data, we can generate some really nice reports in that DMS software. So once we've gone through the effort to plan and walk and figure out, how we want to name these steam traps, how we want to break up the areas, in regards to, how we make it manageable, typically we'll start, you start in the boiler room, then you walk your way out to the distribution lines, and then finally down to where the steam is being used. So all the various areas of where this steam is in use, making note of all the traps within those areas. So again, you want to try to make it manageable. So manageable not only for the work that's done during the survey, but then also manageable from a reporting and documentation point of view. So once we've done all that, we're going to go out and we're going to perform the survey. We're going to take out our spot radiometer for temperature. We're going to take out our ultraprobe. We're going to take out any tags if we want to tag them as we're doing the survey. And I'm going to talk about a way where we've kind of made this a little bit easier for you as far as the reporting and documentation, because we do have a steam trap app that's available now that can do a lot of this stuff for you. But we're going to store the data, and then we're going to review and report the results. And then we need to make sure that we plan for the repairs and improvements. And again, depending on how serious we need to be as far as making the repairs and improvements. But again, we're able to put a dollar amount to it. So we can say, hey, if we repair these traps or if we change out these steam traps, then we're going to realize this savings. And again, that becomes critical in making these plans for the repairs and improvements. And who knows, maybe we find enough wasted energy on our steam traps that are failed or failed open to where we have enough left over to do other types of improvements. So like I said before, we want to make sure that we make contact on the outlet or the discharge side of the trap. So regardless of the type of trap, we always want to make contact, physical contact, on the outlet or the discharge side of the trap. So this trap, or this slide here, just kind of shows where the discharge orifice is on some of these different types of traps. So, you see your inverted bucket here. There's that floating thermostatic like I was talking about. So you have your inlet, and then you've got this curved housing, and then an outlet, fixed orifice. Here's another different style of F&T trap. And if you'd like this presentation, I'd be glad to give you a PDF copy so you got it. But again, the discharge side or the discharge orifice is where we want to make contact, because that's where that turbulence is going to happen if the trap is either leaking by, or if it's failed open, or if it's operating the way that it should. Now, once we're at the trap, we've got to make some decisions. So we've just put together a little decision tree here for you. So, once we're ready to start the inspection, we walk out to that first area where we're going to start, and we come to the first steam trap. We need to determine, is the trap operating? And we want to make sure that the valves are open. If the valves are closed, more than likely that steam trap is not going to be in service. So if that trap is operating, if the valves are open, then we want to check with temperature first. So you always want to check with your spot radiometer first. So if the temperature is cold or the temperature is hot. So if the temperature is cold, we need to determine, again, if the valves are closed, more than likely it's not in service. If we have closed temperature and the valves are open, then it could be a potential where we have a failed closed or a plugged trap to where steam is not reaching the trap. So we'd need to determine that. If we have hot temperatures, then we want to note the inlet temperatures and the outlet temperatures, and then we can proceed to test with ultrasound. Now, once we're ready to test with ultrasound, again, this is where the trap identification comes in. So based off of what we're hearing, we determine, again, if we have a discharge hold, that's going to be with inverted buckets, thermodynamic or disc traps, thermostatics, or continuous flow, that's going to be with your floating thermostatics. Now, we'll determine based off of not only our temperatures, but also what we hear with ultrasound. So, again, I kind of start with temperature first. So if you go up to a steam trap, and let's say we check our inlet temperatures and our outlet temperatures, and let's say those temperatures are the same, pretty safe to determine that that trap is probably in a failed open condition. It should be a little bit cooler on that outlet or the discharge side of the trap. But either way, we're going to listen with ultrasound, and based off of our determination, we're going to determine if that trap is failed closed, failed open, leaking by, or if that trap is working properly. And then we can proceed to our reporting and documentation. Now, for the steam report, you've got a couple of ways that you can generate this. Here is, again, the Steam Trap app. So this app is available in both Google Play and the App Store. So if you go out into Google Play or the App Store and you search UE Systems, the Steam Trap app is one of the apps that you'll see. You'll also see that there's a leak survey app. So that's going to be for compressed air and gas leak detection reporting. I'll go ahead and tell you the other two. There's a route builder app. So you can actually, if you want to set up a mechanical route, for instance, so like a bearing condition monitoring route, you can actually do that right on that route builder app, and then that will send that over to the DMS software. So you can go out and actually walk your line, walk your machines, think about the flow, again, how you want to name your points. So that's what the Route Builder app is. And then the fourth app that you may see would be UE Worlds. So unfortunately with 2020, thanks to COVID, we weren't able to do our annual Ultrasound World Conference. So fingers crossed for next year. But it's that UE Worlds app is just an app for our Ultrasound World and Reliable Asset World conferences. So you can kind of see the agenda and all the events taking place at the conference. But again, the Steam Trap app, that's what the icon looks like. So it'll start you off here. We do begin, and it takes you to Steam Trap number 1. So we can enter in the inlet temperature, the outlet temperature, the orifice size, the test result. Is it working properly? Is it leaking by? Is it failed open? Is it failed closed? Or is it not in service? We have the different manufacturers of steam traps, the type of trap. So that's going to be your floating thermostatic, your inverted bucket, etc. So we allow you the ability to enter in all sorts of information related to that steam trap. And then for the report that the app will generate, so we can enter all that information as we're going through the steam trap survey. And then once we're ready, we can generate a report that will give us then the dollar amount for how much the traps that are leaking by or failed open are costing. But to generate that report, we need to know the type of trap. We need to know the orifice size. If the orifice size is unknown, now a lot of times, steam traps will have a nameplate, so we can get that orifice size off the nameplate. You can do an internet search of the make and model of that trap to get the orifice size. But what I have heard from steam experts, people that I know in the industry that I would consider to be a steam expert, if it's still unknown after those options, then you can default and use 1/8 of an inch. So evidently, 1/8 of an inch is the most common orifice size for steam traps. And then the inlet temperature and outlet temperature, which, as you know, with steam, the temperature equates to a pressure. So the old way that we used to calculate this out would be if you knew your pressure of steam and your orifice size, then you would go to a old-fashioned handy-dandy leak rate table. So then you would go down to your PSI steam and then find your orifice size, and there's going to be a leak rate in pounds per hour across that known orifice. But with steam, as you know, the temperature equates to the pressure. So if we know those inlet and outlet temperatures, then we have a pretty good idea of the steam pressure. Sure, there's going to be a little bit of drop off, but it's going to get us really, really close to the actual PSI steam. So then there's a formula in behind there that based off those temperatures and the orifice size, that's going to give us the cost. Aside from that, we just need to know our cost of steam, so a dollar amount per 1,000 pounds. And then, of course, our operating conditions. So if the trap is okay, if it's leaking, if it's failed open, and then our others, either plugged or not in service. Now, also, if you're using an UltraProbe 15,000 or a 10,000, you can enter all this same information right on board your UltraProbe. And that's what I'm going to show here. So if you are using an UltraProbe 15,000, you can enable different applications. So we can enable the bearing application or the electrical application or the leak application. So in this case, we can actually specify or enable the steam application. And when we do, that's going to allow us to enter application-specific information. So we would then go out into the dB and temp display, and that's what you're seeing here. So you see the decibel level on the left and then the temperature on the right, because again, this has a built-in spot radiometer. We want to make sure that our frequency setting is set to 25 kilohertz, so that you see that in the top right-hand corner of the display from the UltraProbe. Now, it also has an integrated digital camera, so we can also take photos of the steam trap, and we can take as many photos as we want to. So we can take a photo of the trap itself, maybe take a photo of our contact location where we want to make contact, take a photo of the nameplate, etc. And then when we save that data, all those pictures that will populate and then be stored for that steam trap. So then we'll make contact with the stethoscope module. On the outlet side of the trap, we'll squeeze the trigger, and then that's going to activate the temperature, and then we would also see the decibel level or the intensity meter, in this case, going to the right and then to the left. So then on the UltraProbe 15, you have this little icon that looks like a pencil. So what that is that's that input data to where we can input in information that is specific to that particular steam trap that we're testing. So we can enter the test result, the inlet temp, the outlet temp, the manufacturer, the model, the application, what's the purpose of that steam trap, the type of trap, the pipe size, and the orifice size. So you can enter all that information right on board the UltraProbe. And then again, when we're ready to save that data, there's a little icon that looks like a little disk, and that's going to save all that information, link it all together, and then it will advance forward automatically to the next steam trap. So then you would just download that data into the UltraTrend DMS software, and then once you've got it there, within just a couple of clicks, you can generate this this app. I'm sorry, this report. Now you can generate the same report through the app, so it's just a kind of a personal preference as to if you're using, say, an UltraProbe and then storing that data and then downloading it into the software, or if you're using, let's say, the UltraProbe 3000, which doesn't have the ability to actually load a route into it, but yet we can still go out and test steam traps. Well, we can do, we would just need a little spot radiometer, our UltraProbe 3000, and then our steam trap app. So this was a survey where some steam traps were tested, and it's kind of a cropped image because I kind of wanted to have it magnified a little bit. But you can see the traps that you can see here that have been reported. We've got, 2 that are failed open. We have 1, 2, 3, 4 that are leaking by. We have 2 that were determined okay. We had 1 that was a sizing issue, so it wasn't reported, and then we had 1 that was plugged or in the failed closed position. So then the cost of steam, so down below this, there's a cost tab down in the lower left-hand corner, and that's where we would enter in our cost of steam. So in this case, it was $10 per 1,000 pounds. So we had a total cost for the traps that were tested of a little over $16,300 per year. So you'll see that operational time over here. So the default is 24/7, but you can adjust that. So if you know the steam is going to be shut down, or if you know you're going to have, the plant or the factory is going to be shut down so many days a year, you can adjust that, and that will obviously adjust your cost here. Now, then also at UE Systems, we have the defaulted here. So if we have a trap that is leaking by, we're assuming that it's leaking by at 50%. If we have one that's in the failed open position, we're assuming that it's failed open 100%. But if you wanted to make this a little more conservative than it already is, so by default or by design, this is going to be a little bit conservative. So the actual savings is going to be a little bit more than what this reports. But you can make it even more conservative if you wanted to. So you could say that if you have a trap that's leaking by, you could say that it's leaking by at only 40%. Or if you have one that's failed open, you could say that it's only blowing by at 80%. And that in turn would then lower that total cost there. But by nature, it is a little on the conservative side. So just wrapping up here, again, just some things to think about. When you're out initially, planning the survey, we want to take a look at the total steam system itself. Are we set, or are we at the correct pressure for the demand, for what it is that we're doing with the steam? Do we have the right temperatures? Again, we check with temperature first, whether that be, your fancy infrared camera or just a simple spot radiometer. The frequency setting that you want for your UltraProbe, if you have one that has frequency tuning, is 25 kilohertz. We want to make contact, and we want to wait for that trap to cycle. And again, a good rule of thumb is going to be to listen to the trap for about a minute. If you've checked it with temperatures, your temperatures look good, and if we're listening with ultrasound and we haven't heard anything in about a minute, we don't know how long it may be before that trap cycles. So if it's a very low load on the system, or if it's a trap that's only used when things, kick on or come on, then it may be, hours before that steam trap ever does anything. But a good rule of thumb is to about a minute. So you do have to exercise a little bit of patience. Do some research on different steam trap type and operation. I didn't have any sound files of, what traps should sound like. That is located on our website, actually. So I figured it would just be best for you to go there, because sometimes with these online type of meetings, the sound doesn't always come through. But there is a sound recording library, or a sound library, located under the Learning Center of our website. Now, it may ask you to create an account, just basic information, just kind of register with us. If you got the invites for this webinar, you probably already have an account with us. So if you get our emails, But that sound library is located under the Learning Center of our website, and there are some different, typical type of trap, what they should and shouldn't sound like in that sound recording library. A lot initially with ultrasound is going to be about comparison. So before you ever begin the survey, if you have your ultrasound instrument, you got your ultra probe, just go out and start listening to steam traps to kind of get an idea as to what they should and shouldn't sound like. And that will certainly help you out a lot once you actually do your steam trap survey. I talked a little bit in the beginning and throughout about planning. So we want to make sure we have a good plan. It'll make it so much easier. And again, it's very tedious work, especially if you have thousands of steam traps in your facility. But you want to go into it with a good plan. You want to execute well. Again, whoever you're going to have doing the work, doing the survey, the ones actually testing the traps, make sure that they've been trained as to what the purpose, what's their purpose, what the steam traps are doing, what the steam is being used for, and then training on the ultrasound instrument. You've got tremendous resources with us here at UE Systems. It's one of the things that we really pride ourselves in is the amount of support that we offer. So if you have any questions about the particular ultra probe that you have, even if it's not our equipment, we'll still help you out. And we can do that either on site or we've been doing that, a lot of that virtually. So we've got ways that we can do that and help you. Document your findings. Again, anytime you can put a dollar amount to what it is that you're doing, that's just going to really help to create that awareness and buy-in for the need to make improvements to your system. It's also a great way to show the need for additional training or additional condition monitoring tools. So be sure to do that. And then you want to have a good plan to make the repairs. It's one thing to go out and test these traps and find problems, but you also then need to have a good system to make those repairs. You don't want to be finding to the next time you do that steam trap survey, you're finding the same bad traps. We want to make sure that we repair anything that we find that is potentially wrong, and then sustain that program. And then really everything that I've talked about so far will help you to sustain doing that over and over. So again, depending on the size of your facility, how many steam traps you have, what the steam trap is being used for, typically, we'll see people doing and at least at a minimum annual steam trap surveys, but then sometimes it's going to be biannual or twice a year. But a regularly executed steam trap survey, again, can help to provide insight into the overall health of the steam system as a whole. We can make these corrections to the traps that are leaking by or failed, and we can reduce energy waste. And for some of you, depending on where you're located, how the steam is generated, it could be very expensive. So we could be talking about, into the tens, if not hundreds of thousands of dollars the first time you go out to do your steam trap survey as far as your findings. It's very quick, it's accurate, and again, it's going to be a great way to test to make sure that trap is operating and doing what it's supposed to do, and then the versatility of it. So if you invest in a tool, that same tool that you use for steam traps can be used for all those other applications that I mentioned earlier. So with that, that kind of wraps up the presentation. Like I said, if you'd like a PDF copy of this, shoot me an email. I'd love to hear from you. We should have time, I guess, for any questions that came in, Maureen.
Yeah, so we're actually getting pretty close to time. I've responded to some of the questions that have come in. So if we didn't get to yours, we'll definitely hit you up offline. But just kind of one of the common ones, as Adrian said, you can send him an email. His email's up there on the screen, or of course you can always email me as well. And we can get you the presentation, or as I said at the beginning, we did record this, so as I get that up on our YouTube channel, we can send the link over as well, so that you guys can have access to that if you need to rewatch this, or if you've got other folks that you wish had gotten to see it. I will just make note, I'm going to switch the screen back over here to me, that Adrian mentioned, that the app and how you can find it. And I just want to also reiterate with that YouTube page where we post all of the recordings of these webinars, we've also got a ton of tutorial type videos up there, including some really short and to the point videos that show you exactly how to use the apps that were mentioned. So if the Steam Trap app is something that you are going to use, you can certainly go back and re-listen to what Adrian said, but we've also got some pretty quick tutorials with the app actually up and open in front of the screen and everything. So that YouTube channel is a pretty good resource, or at least we hope it is, and we're constantly trying to add to it. So for sure, check that out. There's also some software training webinars as well that you can find. So if you're wanting to dive a little bit more into DMS and actually building these reports and things like that, hopefully you can find what you need there. Just to wrap up, so if Steam is of interest, Adrian certainly did a great job of diving into how you use ultrasound to do your testing. But if you want to learn more, or if you've got someone who's going to be doing the testing, we have a specific online training course for Steam Trap testing, as well as all of our other applications. And we just so happen to be offering some discounts on those right now. So now through the end of the month, kind of our little spooky Halloween promo. We've got all of those at $100 off. So if that was something you're interested in, that puts the Steam Trap class down to $295. And it's a really thorough, interactive course that I think would be beneficial to those that want to dig even deeper into this topic. As I mentioned at the beginning, our Leading Reliability Virtual Conference Round 2 is going to be January 13 to 14. You can check out more information about that, as well as the recordings from all the presentations that were done at the July event. So leadingreliability.com, a great resource. So, as you're trying to do these kind of like lunch and learn things, they're a great thing to sit there and watch while you're eating your lunch. And with that, I'm going to leave our contact info up here. Again, don't hesitate to reach out with anything that you might have questions about or need. We're here to support you guys. And with that, I'll let you all go. Hope everybody has a great rest of your day, rest of your week, and we'll catch you guys later.